I try to go through a little quicker. Sometimes this early stuff, you guys might have noticed, I don't always get through it all because there's just a lot of stuff and I don't know what everyone's skill level. When we get closer into the more advanced stuff, it's a little bit easier to focus in on exactly what to talk about. Okay, so cool. And of course, if there's questions, just as I go through, just let me know. So I'm gonna go share my screen and we'll kind of go through basically this basics of Python. Just give me like a thumbs up to like thumbs down or like on the spectrum of like, how comfortable are you with Python coding? So I see 2 thumbs up on some of them. I see some sideways and stuff. I see a little sideways up. Okay, I see some thumbs peeking out like that. We kind of have, I have this little joke that I've heard this little joke about like asking about, you know, like, oh, thumbs up, thumbs down. It's kind of a good gauge just to see how things are. But in general, it's like, oh, thumbs up really means like sideways. And then like sideways usually means thumbs down, but like, you know, I don't want to hurt your feelings kind of deal. So yeah, I think that's kind of about right. And as you guys get more and more practice, you guys will probably feel a lot more comfortable with Python since we're basically, it's not going away anytime soon. But that's okay if you're not an expert too. All right, so I'm going to kind of go through a little bit of some core Python stuff, some stuff that's from the curriculum, some that's not from the curriculum, but things that I find useful too. Okay, so objectives, I don't even remember this. Oh yeah, so we actually talked a little bit about this last, maybe not last time, but the time before when we talked a little bit about Python stuff. So I'm going to skip over some parts. So we talked about some different data types and stuff like this. We talked about how to check different types and such, like a number stuff. I'm actually going to run some of these cells just because I've already done this. So we talked about different numbers. We just know like strings, integers, floats, booleans like this false here. We also talked about the none type. We said about how we can check the num type right here, which is a built-in function in Python. We also mentioned about strings. For example, we can actually titleize, you know, a string, or we can capitalize a string like this. So we can actually capitalize the very beginning, all that good stuff. We can also make it all lower, which is really useful for data science, especially like we're trying to like find like the words and stuff like this. We don't care about the beginning of the sentence. I mentioned about f strings, so we can do something like a number here. But if I want to put this in a string, right, it's kind of got some, you know, like you can't just simply, if I do type here, you see like, oh yeah, this is going to be a float number. Like, okay, I want this into a string, so I can actually print it out. Because let's say, how do we combine strings together? Someone tell me a little bit. If I want to combine a and then a string, that's like
Concatenate.
Tell me how.
Okay. With a plus sign.
Plus sign would be good. Yeah. Okay, that would be one way to do it, right? So one thing we can't do is we can't just say, oh, let's say I want to say, this is my number. And then say I want the actual number here. I can't do this, right? It gives me an error because you can't add numbers and strings together. Okay, kind of makes sense, right? So what are some ways we could put this together? What make this so we can
str.
STR is good. So we can what we call cast it. So in Python we can cast into a new type, and there's different functions like str. There's also like int and float and stuff like that can convert something into a new type. So you can see here a string. Well, actually, this str will convert this number into a string. And we can add it together. And you'll notice that I didn't put the space in there, but you can see, hey, we can check that out. Okay. And what's nice now too is if I put like a change in this number, say number plus equals 1, it'll actually make it 43. So it's like, okay, cool, that's nice. I will tell you is that this is typically what people will like start off with. This is considered like, I wouldn't say bad practice, but it's usually considered safer to do it another way. And one, I think Nadine actually mentioned about string format. So talk about like str.format like this. If we have something like we're formatting the string, oops. So let's say we have like a string like this, and we can actually format it with whatever we want. So we have like, you know, %1 and something like, or %d or whatever, and we pass it in. This is a nice, really like a nice way to do it. However, if you are using Python version 3.7, I believe, it might be a 3.6, but I think 3.7 definitely has it. We can use something called f strings, which I mentioned last time. And f strings basically allow you to write the string right here directly. And like you can see this little curly brace right here. We can actually say, oh, whatever this is supposed to be inside here, make that as part of the string. And all we have to do essentially to say, hey, this is a special kind of string, we just put an F in front. So if I run this now, it'll actually be, well, 43 is the number right now, so it'll be 44. And you can see here, what's meaning of life? 44, okay? Note that if I don't have this F here and I run this, this will just be this whole string right here. So this can be really useful because you can basically do a little quick calculation here, just outputs and stuff like this. So again, can be really useful. And then of course we can like save this string for later. And then like, you know, let's say like x dot upper. And you can see here, I can just operate on it. Cool. Sound very good? Any questions on that? Any comments? Mm-hmm. Someone have a question? No? Okay, cool. So, all right, moving on to some data structures. So I think last time I mentioned about list. So a list can contain pretty much anything you want, right? In Python. Essentially, it can be a list of numbers, can be a list of strings, can be a list of floats, can be even a list of functions. It can even be a list of lists and stuff like that. And so last time we mentioned about how we can create this list. I think this is actually from the curriculum right here. So you can see a little bit of a list of different things. And we talked about indexing. So we can actually take, you know, certain elements. So for example, if I want the first element, I can just do 0, which will give me the first element. If I want the last element, what's a couple ways we can do this? I showed a couple ways if anyone remembers, but what's one way we can get the last element from top travel cities?
-1.
-1, that's the shortcut way. Yeah, this is the nice Python way. Basically, it's counting from the back. When we do minus, we're counting backwards. There's another way we could do it too. Does anyone remember or have an idea how we could get the last element of this list? It's a little more complicated, but you could do it.
Length of list.
Yeah, so we do length of list, right? So will this work right here?
-1.
Yeah, good. So you notice that you have to do -1. Oops. Oh my gosh, sorry guys. All right, when we get that last one. Note that the reason why we can't do this right here is because this will give us the length of the list, which is, I don't remember what it is, 11, right? So the problem is that our list doesn't go up to 11. So if we do 11 here, it's not there. It's because we count from 0. So we have to do that length of list -1. Okay, and you can see this is a lot longer. So that's why -1 makes it nice and easy. Okay. We also talked about how we can slice multiple parts. So instead of saying, oh, I just want the first one or the second one, I can actually get multiple ones. Like, okay, I go from the beginning here. That's what the shortcut means, all the way to the third one. So you can see here, 1, 2, well, okay, third one meaning like number 3. So 0, 1, 2, 3. Okay. So know that this last part doesn't get included at the very end. We can also do things like slicing between the two. I can also count it backwards. So one kind of quick thing we could do is that if you want just a copy of the list, you can actually just go like this, which will return the whole thing. If you want to say, okay, but I want to count it backwards, like reverse list, this is a very nice, neat thing. You can do -1 and it'll actually count it backwards. If you want to do every other element in that list, so start counting from the beginning, Solta, Buenos Aires, I'm sorry, and then counting every other one you can see here, just skipping over each one. Okay. So some really cool stuff you can do with list indexing. We'll see this again with NumPy. Turns out NumPy really likes using this notation, which is really nice for Python. Okay, cool. Any questions on these lists, guys? That was kind of a review stuff, so we've seen it before, right? Yeah, cool. All right, so just some quick methods. I don't think I talked about this last time, but you guys might be familiar already from the curriculum. We have pop, append, insert, remove, extend. Pop is a really common thing that you'll see in computer science. Basically, it takes the last one from whatever like the stack is, like we say a stack, but like whatever is like the last element, it'll pop off the end of it. Append is just adding it to the end. So pop and append are kind of like the opposites of each other. What's nice about .pop, so I'll kind of show you a little bit of this. Let's we have a .pop. What element should this return for A? You can show me with your fingers if you want. All right, see 3, yeah, 3. Everyone's got a different ways to show 3. So yeah, we say A.pop 3. What's cool, let's see if we have this. What is A gonna be? Is A gonna still be a 1, 2, 3? Yeah, it's only be 2 because it popped it off, right? So note that basically pop will actually remove it, which is very different from A, let's say -1, right? Because A will still be A. So there's a little difference there. You can also do .remove and stuff like this. To be honest, .remove and .extend aren't as common. I like rarely use it. In fact, when I saw .extend in the curriculum, I was like, wait, you can do that? Like I forgot, like it's not something I usually think of. So you can see here, extend basically, we can add more onto the list kind of deal. So, or kind of add the list together. So if you can look at like print A and print B, you can see we have A, 1, 2, 3, and then 1, 2, 3 in words. If we actually do extend now, so I'm going to extend A, and you'll see this is going to be the new A, and you can see here now we have 1, 2, 3, which is the original A, and then we extend it out by this part. We also could have done equivalent thing where we add them together. So for example, just rerun this. So we have A and B. I'm gonna comp this out. So you can see A, B, 1, 2, 3, and we can do A plus B. And this will actually just combine them together. So when you add lists together, you can actually just put them together kind of like strings. In fact, fun fact, so your string, this is actually just like a list. So I can actually pull out the first letter of that list. Or I can say, okay, let me get the first 5 letters, and you can see here like this. So strings are actually just like lists in Python. So you can actually do the same thing. So that's why we can actually add in, you know, another string like this, because this is basically just considered a list. Okay.
That's actually really useful to know. I would never have guessed.
Yeah, yeah. So it's kind of an interesting Python thing. Lists and strings are basically the same thing in Python. So yeah, cool. All right, any questions? No? All right, cool. And that's also why you can do len string. You can also count how many characters there are in a string. So it's just like a list. Cool. Right. This will come in useful too when we talk about for loops. All right. One thing I noted here is that, for example, if I have like C, I can do A plus B, right? You can 1, 2, 3. But let's say we want to add some elements. We can actually add this list here. Note that we can't just add, like, let's say if I do like here, we'll now have 100, 1,100 on the end. But if I just did like +1 here, note that this won't work because a number plus a list isn't going to work. It's like, hey, you can't add an integer to, you know, a list. But if I go ahead and wrap it around like this, you'll see now, like, it'll work. Okay. So note that also we had like that number, right? Which was, is it 44 now? I think it's 44 or 43. We'll find out. We can actually add that into our list as well. It's 43. Okay. So some useful things. Note that we can also create a list of lists. So these are called nested lists, which can be very, very like confusing. Right here, you can see like I have A. I actually have it referenced within here. So A is actually this whole element here. Okay. In fact, if I keep running this, you'll see this list probably getting bigger and bigger. So you can see nested list within listed list. Okay. Cool. Any questions? I know I'm going by this really quickly, but I figure you guys have seen most of these things. Yeah. All right, awesome. So dictionaries, which is one of my favorite things because I just think they're so cool. So one thing to know about dictionaries, who knows another programming language by chance? If, like, maybe someone's from a computer science background. Okay, I see some hands up. If you're from another programming language, you might hear, if you know what hash maps are, dictionaries are basically hash maps. They're nearly equivalent to the same thing. There's some slight differences, but they're pretty close. The main thing with a dictionary, it's kind of like a list, but we have a very big difference where it's a key and a value. Lists actually kind of have this, where essentially in a dictionary, you have the key, and whatever the key is, you can then pull out the value from that dictionary. If we were kind of comparing this with a list, what would be a key for a list? Like, what would that thing be, you think? How do we know what element to pull out on a list?
The indexes.
The index, right? Whether it's 0, 1, 2, 3. It's kind of like that key is like the order, and a dictionary just allows us to use whatever key we want. So there isn't an exact order of a dictionary. There are some modifications with dictionaries. For example, with collections, you can actually make an ordered dictionary. But the main idea is a dictionary basically has a key and a value. So they have key value pairs. Okay. So the way we create this in Python here is we actually use this curly brace, and we have our key. So this key can be anything you want, right? Any kind of object, a number, it can be a string, it can be other things and stuff like that. Something that's, I shouldn't say it shouldn't be anything, but it has to be immutable. And you're like, whoa, what does that mean? Immutable just means that you can't change that value. So for example, if I have equals a string like this, oops, I didn't mean to do that. X like this, we can do this perfectly fine. However, a list we can always change, and this one will give me an error. Say, hey, you can't do this, and that's because we can change the value of that list. So note that basically a key has to be something that value itself cannot change. The variable can change, but the value can't change, and that's what the big difference is. A little subtle, but it's called immutable. So anyway, it's mostly whatever we want to be. I don't put those nuances, so you're like, try this out. But anyway, we have our key, and then we actually have this colon here that says, hey, whatever this key is, this points to this value. And then we have this key points to this value. So you can see the number 1. And this key, which is the number 10, points to this value. Simple enough, right? Note that we can also have multiple keys point to the same value. So you can see here, this actually points to the same one. Note that values do not have to be immutable. So I could have done like x equals a list. Remember, that couldn't have been a key, right? I can actually point that to the same one. So this will be perfectly fine. And that means just 10 and 11 point to the same exact variable.
Sure.
Yeah.
Are they the same values in the memory too?
Yes, it's actually, so if you're familiar with memory, basically, I'm going to kind of explain this as quickly as possible to people who aren't familiar with memory. Basically, it's like your variable is kind of like a box. And so when we say the variable x, it's like saying, hey, go check out this box. So for example, if I put like the number, like in this list, the number 1 in here, it means like whenever I say x, like, oh, it's pointing to this list of 1. So this x right here isn't a copy of it. It's actually pointing to this direct, box. If I had something like y equals like this, I'm not confusing anyone too badly here, but this will basically say, okay, they look like they're the same value, but they're actually different things. X points to the box that contains, the list 1, and then y is a different box that also just contains the same stuff, right? The equivalent to this is like, I'm about to have twins, in a few months, is that my twins are not going to be the same person, but they might have the same DNA. So it's like, oh, they're different people. But if I like poke a twin, the other one doesn't feel it. I mean, hopefully not. But anyway, okay. Yeah. So maybe we'll go into more details about this. This can get very complicated, but I don't want to go there. But yes, if you know about memory, if you point it to the same variable, this would be the same thing. I'm going to change this out because so not to confuse anyone too badly. Okay. So we have a dictionary. So it's like, okay, cool. We have a dictionary. We got some key value pairs. How do we get that value? Well, just like in a list, we just, in the list we had getting the first element. Ooh, this is going to be messy. But getting that first element, we can just A, and that will give us the first element. That's super confusing. But anyway, maybe B is a better idea. B, we can get that first element in that list. Well, in a dictionary, we can't use necessarily, saying the first element in the dictionary. So this D0, there isn't a 0th element in this case. We didn't define it as a key. So you'll get a key error. It doesn't exist. But if we do have actual key here, we can get it just like we did with a list. And you can see here, other key, which is 1. So if I wanted to see the value that's associated with 10, we can just do 10. And that will give us this guy. Cool. Everyone follow me so far? Okay, so you can almost think of like a dictionary as like a generic list. It's kind of like, oh, you can put the keys however you want. However, you saw like if I had like something like, the 0 here and I expected it to be in the dictionary, but it's not, I get this error where it's like, ugh, annoying, right? Which, you love to learn errors, but it's not the best thing. You kind of want something to happen. So one thing you can do, like I see not a key, if I do this, it gives me an error. It's like, well, I don't want it to error, like that's annoying, right? So one thing I can do, and I'll just get rid of this print real quick, is if I do d.get and then try to get the key, this will actually not error. It'll just like, hey, look, it didn't give me an error. Like, what's up with that? Like, that's pretty nice. What happens is actually returning none. You can see here, basically, it's just saying, hey, D, get that key. Hey, the value, there isn't a value in here. It's none. But it's like, you know what? I really don't want it to give none. I want it a very specific value if it's not in the dictionary. I can actually pass it in like a specific value. So you can see here, I can do d.get a certain key, right? And say, oh, just give it 0. And you can see here, that's the default value if that key doesn't exist. Okay. So this is like the safer way. So for example, I can still do d. What's one of the keys we have in there? String key. Oops. Yeah. That's what happens when I do things on the fly. You can see I can get that string value. So you can do this safely that way. Note that if I also put in like a default value of like, 100,000 or something like that, it'll still give me a string value. But if it doesn't exist, it'll give me that default value. Cool. So again, very useful. Any questions on this, getting the value from the key?
Yeah, I definitely have a question on the .get.
Yeah.
Now, is the key of, or sorry, is the value of 10,000 assigned to the not a key?
Oh, good point, right? Yeah, so let's say we have this guy right here, right? And we run this. And you're like, oh, it gave me back 1,000. It's like, okay, did it like what did it do? Like, did it change the dictionary now? So one thing we can actually do is actually print out the dictionary. And you can see here, the dictionary itself has not changed. So now if we actually try to get, let's say we just go ahead and try to pass this in like as if it was in the dictionary, you'll see, it didn't work. So yeah, all it's doing basically is saying, oh, this is not in there, just give it the value 100,000 or whatever you put right here. But it doesn't modify the dictionary itself.
I see. Thank you.
No problem. Cool. Actually, I wonder now. I actually wonder, okay, yeah. I was like, can you actually do that? There might be a function that already exists that does modify the dictionary, but I don't know it, so we will skip over that. All right, so kind of doing some elements of dictionary. So this actually, if you've gone through the Macbeth project, who's gone through the Macbeth or has reached that point? And give me a thumbs up, thumbs down to how you felt about that project. All right, thumbs up, thumbs down. Usually what I get is kind of like took me some time. That was a little tough because there's some funky stuff in Macbeth. But if you look at the solution for the curriculums, part, you will see like some of these things used for dictionary and stuff. So one is we have our dictionary here. Some things we can do with it, right? One is we can see how long the dictionary is because it's kind of like a list. We still have number of elements in there, right? In this case, there's only 1, 2, 3 key value pairs, right? But if we wanted to specifically like, hey, what are the keys what can I ask the dictionary for? Let's say someone made this dictionary or it's way, so many lines above and you don't remember what it is, you can actually check out what the keys are. So you can do d.keys and this will give you the list of keys. Note that this is something a little funky. If you look, say, hey, wait, why does it say dict keys here? And the way you can kind of think about this, let's say I have like D keys. Okay, and it's like, well, okay, this is now like kind of like a list, right? That's what it kind of looks like. In fact, if I try to go like grab the first one, you see I get an error here. And that's because it's Python 3 introduced this idea of different types and stuff like this that would be returned. So for the record, if anyone talks about Python 2, they're already outdated. Python 2 officially went outdated January 1st of this year. I think a specific time even. But anyway, it was outdated. It's not going to be updated anymore. So don't use Python 2. But in Python 2, this would give you like a list. So it's like, well, I like lists, lists are just friendly. I remember it. It just doesn't seem that bad. I can do this casting. This will convert it into a list. And now if you look at this, hey, it looks like a normal list. And just to double check, is that the right type? You should see list. There it is. So now what we can do, remember before when I tried to actually get the first element in that list, or that list, I would try to do 0. It actually works this time. It's like, oh, I can actually get the first element in that list. The reason why this kind of makes sense when you don't have lists like this is because the keys, do they really have an order? And it's like, not really. Like, they don't really have an order. It's just that they happen the order of whatever you pass it in. So that's why you can't just simply pull out that number. Okay, but just some subtleties there. But anyway, we can get the keys directly. We can also do something very similar with d.values. So if I do d.values, you can see here, it has a special funky type. We see the different values. In fact, if I did now list and then say, oh, let me just get the second value, which should be 1. See 1. Okay, cool. Everyone following me so far? All right, so now I'm going to crack my fingers a little bit and say, all right, get some funky Python stuff. D.items. Has anyone tried D.items before? I see some thumbs up. All right, so D.items, if you don't know what it is, so if you do know what it is, don't say anything. Someone who doesn't know what it is, what do you think D.items would give you? I'm gonna guess. Enough that you can say like a list or whatever. I thought I might have heard someone. No brave soul. Maybe it's a trick. Maybe items doesn't exist. All right, so let's try it. D.items. So D.items actually gives, and I'm going to put this a list just to make it a little bit easier for us to read. So we can kind of treat these as lists, right? You can see here, basically it gives us quote unquote a list of these key and then value pairs. So this right here, you'll notice that it's not a square brace like we've seen like in list. This is something called a tuple. And yes, that is the fact of what it's called. It is called a tuple, which I think it comes from the fact that like tuples can have 2 things in them. However, tuples can also have more than 2 things in it, which also makes it super confusing. But if I actually try to take out that very first element, we can see the first element is going to be this thing. So you can see that string and then string value, or string key and string value. So the D.items actually gives a pair of the key and the value together, which can be really useful. Just to prove to you guys that I'm not making things up, like what is this tuple thing? Like, are you sure, Victor? Like, I think you're a liar. It is a tuple. Okay. So again, funky thing. Note that we can define our own tuple, so this is kind of a little sidetrack. But a tuple, let's say, for example, I do like A equals 1, 2, 3. Note this is not a list, right? I can actually do this, and you can see the type. Oops, press the wrong buttons today. Cool. Okay. So what's nice about tuple, basically these are in a mutable list. Basically, I can't change this value. This value is set in stone versus a list can be like added and stuff like this. For example, I can't do a dot append. You'll see, hey, you can't do that. This has no attribute append because basically tuples stay the same. But we can kind of reference it like a list. So we can do like the first element in a list. So for A0 will actually give me the number 1, right? This is going to be confusing, but A1 gives me the number 2, it's the second element, right? And A3, or A2 gives me the number 3. And of course I can get the last element just like a list. So note that it kind of acts the same way as a list, but it's in fact a tuple. Okay. One thing I should note too, you go like, let's say 2 different elements in there, it also returns a tuple. It doesn't return a list. Okay. So anyway, that is what D items, long-winded thing about saying what D items gives. Basically, it's a list of tuples, which each tuple is a key comma value pair.
Sorry, one question.
Yeah.
So, sorry, when it comes to tuples, it's like the things within it can't be changed, but it can be referenced like in the same way you would reference elements in a list, right? Like you did slicing and stuff.
Yeah, that's right. It's you can still like it's got an order to it. It operates the same way as a list. Python has a lot of these kind of like, oh, it acts like this, but it has some special properties to it. A tuple is just one of those things where it's like a list. It's technically immutable, meaning it's like value is set in stone. So it's like a tuple is equivalent to saying, you know, like let's say 1, 2, 3. It's the same thing as saying 1. Like you can't change this value. Like I can change a variable. Like if I have x equals 1 and then I do like x plus 1, that's not really changing 1 though, right? This is really just saying 1 and that's like innate to the number 1 versus like a list. A list in Python, this is getting a little more computer sciencey, but a list in Python basically exists where it can change in like size and stuff. It's not set in stone. Like this by itself, you know, say 1, 2, 3. This can actually, like in Python, I'm trying to give a good example of this, but basically Python says this thing does not like exist as like by itself. It's not, I'm going all over the place right now, but I'm thinking like atoms. It's like, oh, like you can't like you can keep tearing this apart and this would be like individual parts of the list, where a tuple treats this as like, oh no, this is one thing that you cannot just like say it's something different. It's like, oh, the value of 1, 2, 3, if that makes sense. Yeah. I will tell you is that immutable and mutable values can be very confusing. Could someone said in the chat? Good, Edward, you can also put mutable objects inside of a tuple. Very good point. So Edward pointed out that you can put mutable values within a tuple, which makes the whole idea of this being immutable and stuff like this, it's super confusing. So I'm debating if I should even show you guys this because I actually don't remember what would do it. Well, let's go for it. So we can actually do this guy. Let's say this is going to be our x. Let's call this x tuple, z tuple because I mistyped it. All right. So z tuple. Yeah. There we go. So z tuple. So I actually don't know what's going to happen here. So fun little game. If I do z tuple, right, we can see it's like, oh, okay, that changes, right? Or like it's the same here. But let's say we can change x, right? So like we can do like x dot append 1, right? So this would actually change x. So it should be instead of 1, 23, it'll be 1, 23, 1, right? So I believe z tuple, anyone got a guess? Will it give us 1, 2, 3, like this value, or do you think it will be 1, 2, 3, brace 1, 2, 23, 1? So basically, will this value change or not? Any guesses?
I think it'll add the 1.
You think it will change? You think
Yeah,
it'll have the 1 here?
Yeah.
Yeah. Okay, I see some thumbs up with that. I think that's what would happen, and I think I can argue why it would, but I can also see it going the opposite direction. Let's see. Yes, it will add the 1, and that's because of this guy right here. is representing not the value, but like the memory space of that value. Again, I'm so sorry if you're not familiar with this, because you're probably like, I don't know what's wrong with you, Victor. That seems really obvious. It doesn't seem anything big. Memory spaces can get very, very confusing. Memory location areas. But anyway, fun little sidetrack. I don't know if I learned something new, but I confirmed something I maybe knew before. All right, let's move on away from tuples and lists, because we got some other stuff to talk about.
Can I just say that
Yeah.
what I think it is,
Mhm.
is that the item in the tuple is a reference. So the reference can't change, but
That's a good point.
but the memory that reference points to, what's in that memory can't change.
I think you're right on that. I think that's absolutely it. And again, I'm so sorry if you guys like aren't from computer science background, because that's kind of the stuff that you would talk about a lot. In Python, usually it's kind of just like a little bit hidden behind the scenes. But we'll probably come back to this when we talk about object-oriented programming and stuff. Okay,